Hello, well, it's October 23rd. Finished working about 40 minutes ago. And we have still 9 test cases to pass. Oh, don't worry. I'll get it done. Sometime. Oh, I need to log in again. What the hell? I think now they run a much shorter period. I think in the past it's almost forever, right? I don't even remember it logging me out in the past. But now it just, logging me out, I guess, every week. Oh, what happened now? Oh, wow, what the hell? I just want to do problems. I don't know, something is wrong. Let me see if I can refresh it. All right, exit, reload. Okay, now we're good. Next, greater numerically balanced number. An integer x is numerically balanced if for every digit d in the number there are exactly d occurrences of that digit. Give integer n, return the smallest numerically balanced number strictly greater than n. So x is balanced if every digit in it there are exactly d occurrences of that digit. So give an integer n and return the smallest that is strictly greater than n. So in the first one, n is equal to 1. So strictly greater, so it starts with 2, right? So if you do 2, you need to do 2, 2. If you do 3, you have to do 3, 3, 3, right? They are strictly cannot do 1. Okay, so now this is 1,000. So it need to be bigger than 1,000. And you cannot have 0 because you'd have 0 occurrence of 0, which doesn't make any sense. So basically, my option is 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, to 9, all 9s. But it doesn't have to be together. We can always order them. Maybe. So how do we do this? We say 1, okay, we have 1, 1. And we can do a single 1. But yeah, so we can do a single 1. And then 0, I cannot do 1, so next option is 2, right? But I can have 2, 2, but then I don't have anything left. So I have 3 left, so the only option is 3, 3, 3. 3,000. So I say I start with 3, but I have a 3, I need to have 3, 3. But then I have 1 more, I can do 1, so I put it here. What are the, is it like just to analyze, or we can try it out? Well, for 1, given the number of digits, I think we know, right? So number of digits is 4. And we need, so it's either 1, 3, or 2, 2. We cannot do 2, 2, so it's only 1, 3. So those are the only 2 digits that can be put in here. And then you just need to arrange them such that it's slightly bigger than this. Okay, so 4, it has to be 1, 3, right? So 1, there is not possible. So if it's a 1 digit, right? It's the length of digits. So 1 digit is definitely just 2, 2. That's determined. If we have 2 digits, right? We can do 1, 1, but that's not going to work. So depending on 2 digits, if 2 digits is smaller than 22, then we do 22. Right? If it's smaller, let's do it this way. Let's kind of just analyze it. If we have 1 digit, that's going to be 2, 2. 2 digits, if it's smaller than 2, 2, that's going to be 2, 2. Otherwise, it's gonna be 333. Right, that's 2-digit because you don't have, so 3-digit. 3-digit, we can do 1 plus 2, right? Which means we can have 1, 2, 2, right? 1, 2, 2, and yeah, let's see if we can use 1, 2, 2 to fit this. And how do we fit? So we see what's the first one, right? If the first one's a 1, the second one, right? So yeah, that's the only possibility. You don't have, you have 3 or 3 or 0 plus. So you have like 1, 2, 2, right? And then 2, 1, 2, and 2, 2, 1. That's it. That's the only possibilities. And also I have 3, 3, 3. That's that. So these are your options. I'm actually listing the options right now. Right? 2-digit, 3-digit, right now 4-digit. 4-digit, of course we have 4, 4, 4, 4. But then only 1, 3, 3, 3, and then a bunch of options: 3, 1, 3, 3, 3, 3, 1, 3, and then 3, 3, 3, 1. That's it. That's the only options. 5-digit. Okay, so we have 1 with 4, and then all the combination of this, or 2, 2, and 3, 3, 3, all the combination of this. Has a combination of permutation. Ooh, we want to find all of them. And also we have 5, 5, 5, 5. Ooh, that is going to, this is fine. How do I do this one? Well, technically you have 3, 3, 3. You have these, so you put 2 and 2 in it. All right, and put 2 and 2 in it. How do I know how many different ways. So 1, 2, 3, 4. So 4 choose 2. That's 6 different ways. Actually not that much. We can hard code everything. All right, we can hard code everything. And then now we have 6. 6 is gonna be 1 and 5, right? Which is simple. 2 and 4, simple. 3 and 3 is not possible. 4 and 2, and then all 6. That's it. That's all. That is all. Because the largest is the 10 to the 6, which means 10 to the 6 is what? 1, 2, 3, 4, 5, 6. That's 10 to the 6. I have 6 zeros. So we need 7-digit. Actually, no. 7-digit. If it's 10 to the 6, right? If n take 10 to the 6, and the only option is 1, 6, 6, 6, 6, 6, 6. That's the only option, right? That's the only. So I actually don't have to consider it. The rest will put that into a so actually the difficulty is to produce all possibilities, right? All possibilities. We can just, I don't know, what would the what will be the easiest way to do that? Actually, it's not true because the 2, 2 can both show up here and both show up here. So we don't have to. What would be the better way to? If you do run to permute, that's going to take a long time to permute. What would be the faster way to handle this, to get all possible arrangement all possible arrangement. Because my ideal is we get all the arrangement and then we just do a binary search, right? It'll be very simple. But how do I get the arrangement? Well, I think you can probably, you have like, let's say we have 5 positions, right? 1, 2, 3, 4, 5. I can say first I'll take 2, or I can do first take 3, and then the next I can take 2, or I can take 3. It's just you do that, and then you will, and then we backtrack. We backtrack. So each position. So once we're done, right? Like 2 and 2 we don't have, so the rest we can just go straight ahead. Right? Go straight ahead. And then we'll do 3, it's fine, and then next. So whenever one of them is done, and the rest is straight ahead. And it's unique because at each step, it's always going to be unique. So we'll write a function that will produce all possible combination of this, and we'll do it as a string, and then when it come out, it will be an int. Okay, so let's try this idea. Okay, so it's 2048. Produce all possible what's it called? Numerically balanced, right? Numerically balanced numbers up to 6 digits long. Sort them and then binary search for n. That's it. So we do need to have a function called auto gen. Oh, gen. Gen nums. We don't take anything. We need to take. Oh, I realized we can do 1, 2, 3 for 6. 1, 2, and 3. Holy crap. How do I do 1, 2, 3? It's the same. It's the same because I know all the 2 3s, right? And we just put 1 in them. That's actually a better idea. So like if I have all the 2 4s, I just put 2 in them. What? Hold on. All different. We can do like a 1, 3. There's no systematic way to do this. I'm thinking. You know what? I think I'm just gonna go the most stupid way, which is I'll just do it this way. So what I'm gonna pass in is going to be another map. But you need to know what is in it. Counter. I mean, at most is 6, right? So actually no. Let's do a vector int counter. And what are we going to return? So instead of return something, let's just put it in a nums. Okay. So yeah, so that's that, and then we'll use it, and then we'll return it. All right. So basically, at each round, we will go through, and then we say for int d equal to 1, d smaller equal to you can say max d, right? So we say int max digit is going to be 6. It cannot be larger than 6, right? Max digit is 6. And we can take this. So smaller equal to max digit d++, right? So if we say counter d is larger than 0, then we'll take d for the current position. We also need int index, right? Position and index. So if index is larger than max d, right? Max d is the longest. Actually, one thing will be easier. Equal to counter.size, which means I have filled through. No. What is this index? No, there's no index. What it is I need to have a string. Right, I need to have a string of current. Okay, that's the current number. What I do is I go check the counter, right? If number left, right? Number left. So this is current remain. Okay. So we say if remain is equal to 0, we don't have any remain. Then current is what we have. Then we say nums dot pushback s2I current. I think that's it. You know what? I don't need this. I can just, yeah, no, I think int current. I can do int current. Okay, and then we'll just return, right? This one done. If remain is equal to 0. Otherwise, remain is not equal to 0, then we go through all the digits and we find the first digit that's larger than 0. Okay, Then what we do, we say counter d minus minus, so we reduce this, and then we say gen nums. You know what? Yeah, let me just define it here. Void gen nums. Oh, then we have the max d. I forgot how to get lambda function type. How do I do the type? Input and output, right? Okay, so instead of do this, we say std function. So input, wait, hold a second. How do I do complex input and output? I just want examples. You have examples? Just int to int. Oh, here. Oh, this is output. This is input. Okay. So output, how about the void? I guess we can do void. All right, int vector. Then we do this. Okay, so we'll say current times 10 plus d, remain minus 1, counter, and nums. Right, so a gen nums, after we generate it, counter d plus plus. We put it back. Right, we put it back, and we choose the next one. We choose the next one. So each position will choose a different one. I don't think this will give me any duplicates, because at each position I choose a different one. It's guaranteed to be different, right? And then for this, blah blah blah, and at the end we're done, right? So that's that. That's this function. So what we next do is generate all possible numerically balanced numbers. So what do we need? So what we need is vector nums. There's a 1 digit. No, 2 2. No, 1 2 2 3 3 3 and no 1 1 2 2 2 1 2 2 2 1 3 3 3. 4 is going to be 1 3 3 3 3 1 3 3 3 3 3 1 4 4 4 4, right? And then 5, so the easy ones we can produce by hand. The more complex ones we will use the gen nums function. Right, so complex ones are 2 22333. Right, I have 22333, which is 5. But the easier ones are 1 4 4 4 4, right? 4 1 4 4 4, 4 4 1 4 4, 4 4 4 1 4, 4 4 4 4 4 1, and 1 2 3 4 5 5, and then 6. 5 6 1 2 2 3 3 3 6, and then 6 5 2 4, right? 1 5 2 4 3 3 is not possible. So yeah, these are the only difficult ones. So again, we have 1 1 2 3 4 5, 1 2 3 4 5, 5 1 5 5 1 5 5 5 5 5 5 1 5 5 5 5 5 5 1 5 5 5 5 5 5 1, and of course 1 2 3 4 5 6, and 1 1 2 3 4 5 6. That's it. So that's the number, and then we can call complex number, this, and then complex auto gen this, okay, auto gen this, and then auto gen this. Oh, max D, I should push max D into it. I actually don't need int, it is the vector length, the counter length. I don't need max D. Who need max D? It's counter size. So in this case, we can call gen nums I don't think it's possible. Okay, so what we can do is vector int counter. Oh, we start with 4. Okay, and then we say counter 2 equal to 2, counter 3 equal to 3. So we'll pass. Okay, we'll start with 0. Current 0. Remaining is 5. Alright, current, remaining, counter, and nums. So counter dot clear, counter 1, counter 2, and counter 3. Gen nums 0 5, counter nums. Okay, this one counter dot clear, and counter dot resize 5, counter 1, no, 2 equal to 2, counter 4 equal to 4, gen nums 0 6, counter nums. Alright, then sort and binary search. Sort nums dot begin, nums dot end. Okay, we'll find the first one. So we want upper bound. Wait, hold on. What do we want? We want the smallest strictly greater than. Yeah, upper bound. So we can return. Right? We can return upper bound. Nums dot begin, nums dot end, n. So upper bound is the smallest one, is larger than. Right, and then we can do, I think we can do this, right? All right, I'm actually not sure. Does it work? Let's give. Oh, 3. Right, 1, 2, 3. And then, of course, 1, 2, 3, 4, 6. Oh! My bad. Oh, shoot. Oh, darn it. Yeah, I forgot. Auto. So 1, 5. No, 6. 1, 6. So what are 6? When all 6, we have 5, 1. Right, we have 5 and 1. We have 2 and 4. So all the 5s. Alright, all the 5s. All the 5s. No, all the 6, my bad. All the 6. All the 6. 6 we have 2, 4. So 1, 5, 2, 4, and 6. I don't think we need 6, because 1, 6 will be enough. Right? It's actually my bad. This is the largest. Yeah, I got this one wrong. So it's 1, 2, 2, 4, 4, 4, 4. The largest possible is 7 digits, right? 7 digits. 1, 2, 2, 4, 4, 4, 4. That's it. It cannot be. Okay, so let's take a look at this. I just realized even if I have duplicates, it's fine. It's not gonna matter. Let's just one more to kind of kick things around. No. Six digit. I have 1, 2, 3. It didn't work. Apparently it did not work. Holy crap. Alright. That is unexpected. What do we have? What the hell is that? My bad. Alright, let's see. I don't have. Oh shoot. 6. Okay, that is no. This is 5. My bad, man. This is 5. This is 5. This is 5. No, this is 6. And this is also 6. So 3, 4. So 2, 2, 3, 3, 3, 2, 3. Yeah, I got 2, 3, right? Looks right. 4, 1, 5. 1, 5, 2, 5. 2, 2, 4, 4, 4. I don't understand. What how happened to the 1, 2, 3? Huh? I don't understand. I don't understand at all. Hold on. This is weird. This is very weird. Like, this thing doesn't seem to work. And I have 2, 4. But I don't have this 1, 2, 3. Why? I am going to do some debugging here. Yeah, I feel we're almost there. That's why I don't want to use other resources to debug. I feel this shall be enough. Right, this shall be enough. I think it's the clear that's giving us trouble. Factor clear. Oh, size becomes 0. Oh, I think it should be resized. Oh yeah, hold on. How to clear all elements while maintaining the same size? This is the question. Clear and followed by resize. Got it. So what I need is, this is a fine and blah blah blah. So clear resize 4. Right, and then this is not 5. This should be 6. Clear resize. Yes, that's why this one works. Okay, so I think this shall work. Yep, this one works. This one does not work. Did I not produce 3313? That is bonkers. What? Oh, you missed that. Holy crap. I did miss that. My bad. 313. I missed it. 3313. Ah, shoot. Plus, I just realized I don't have to go through all of them, depending on the number of digits. Right? So we just say if string nstr nstr I to s. Now I think I can just do string this size. We can say int num digits comes from int, or is this like toString? Yeah. Okay, so we say if num digits, right? Num digits is larger equal to 4. No, larger equal to 5. Then we'll do this. Right, because this is 5, this is 6. Larger equal to 5, we'll do this. If it's not, then we don't even do it. And I only use it once, so I don't even need to use this here. I can just do it here. Right? Otherwise, we'll just do the rest. Okay. An interesting problem. I love a brute force. Let's use the test case. All right, submit it. That's it. Good. Brute force. Ah, fun problem. Alright, we're gonna take a quick look at the editorial. Enumeration. Oh my goodness. It just lit. I thought mine was brute force. This is the true brute force. Oh yeah, they just go through all possibilities and then we just check if it's balanced. Okay. Yeah, that worked. That worked. Lookup table. Yeah, it's a little bit tough on some of them. To if you don't use an algorithm to generate all of them.